Good day, viewers all over the world. Today we want to look at initial and boundary value problems. That is, when you have a differential equation and you are given subsidiary conditions, additional conditions on that. If we invoke additional conditions on that differential equations, it either becomes an initial value problem or boundary value problem. So what do we understand by initial value problem and boundary value problem, and what is the difference between the two? That's what we want to look at. A differential equation along with subsidiary conditions on the unknown function and its derivatives, all given at the same value of the independent variables, constitutes an initial value problem. That is, when you have some additional conditions invoked on the differential equation, and if the unknown function, if the independent variable, if the unknown function are given at the same time, at the same point of the independent variable, that constitutes an initial value problem. Then if the subsidiary conditions are given at more than one value of the independent variables, then the problem is boundary value problem. So when it is initial value problem, they are given at the same independent variable. But when they are given a different independent variable, it constitutes a boundary value problem. For instance, this problem, when we have y prime prime plus 2y prime is equal to exponential x. This is a differential equation. This is a second order differential equation. This is a differential equation. Okay, that's just in differential equation. But if we invoke additional condition on this differential equation, that is when we have something like y prime is equal to 1 and y prime of pi is equal to 2. So we have added conditions to this differential equation. This is a differential equation. Once we decide to add conditions on a differential equation, it either becomes an initial value problem or boundary value problem. But in this case now, look at this condition. The conditions that were added to this differential equation in this case were given at the same independent variable, y of pi, y of pi, then y prime of pi. The value of x at these 2 points are pi. Then in this case now, this is an initial value problem. So it's an initial value problem. But if you are given this initial value, if you are given this, let's say we are given this differential equation, and these conditions, and with this condition, y of 0 is equal to 1, and y of 1 is equal to 1. In this case now, we are given the value of x at equal to 0 and s at equal to 1. Then this is a boundary value problem at different value of an independent variable. With this differential equation, is called boundary value problem. The same independent variable, the function and the derivative are the same value of x. With this differential equation, is called initial value problem. So that is the difference between boundary value problem and initial value problem. In case of initial value problem, all the subsidiary condition of the unknown function and its derivative, all are given at the same value of independent variable, pi. When x is equal to pi, here x is equal to pi. In this case also, x is also equal to pi. But in this second condition, x is equal to 0 or x is equal to 1. So when the subsidiary conditions are given at different independent variable, such problem are referred to as boundary value problem. But when they are given at the same, it is called initial value problem. And note, once we have a differential equation and we decide to add subsidiary conditions on any differential equation, it becomes either initial value problem or boundary value problem, depending on what type of conditions that we decide to attach to that differential equations. So let's take one example on this. Let's take one example. Just take only one example on this, then we close the class. So let's take one example on this. Okay, example. Let's take one example of this. The question says determine the value, let's say determine C1 and C2. Determine C1 and C2 so that y of x is equal to C1 e2x plus C2 ex plus sine x plus 2 sine x plus 2 sine x will satisfy the condition. We satisfy the conditions y of 0 is equal to 0 and y prime of 0 is equal to 1. So let's look at this problem. I want us to look at this problem very well. Let's look at this problem. What type of problem is this? In this case now, we are given a differential equation y of x. We are given a function y of x, which is equal to C1 e2x plus C2 e raised by x plus 2 sine x. So we want to determine the value of C1 and C2. Then this is the condition. Then we are given this condition y of 0 is equal to 0 and y prime of 0 is equal to 1. So what type of problem is this? In this case now, we realize that the value of the independent variable is the same. 0, 0 at x equal to 0 and x equal to 0. So this type of problem is called the initial value problem. It is called the initial value problem. When we have a differential equation plus subsidiary condition, depending on the condition, this type of condition now is called initial value problem because it is the same. It's at the same value of x independent variable. So what do we do here? How do we get the value of C1 and C2? Of course, when we have y of 0, this is y. By the time we differentiate this, we are going to get, when we differentiate exponential function, we only differentiate the power. Then use it to multiply. This will be 2C1 e raised by 2x plus C2 e raised by x plus, when we differentiate sign, it's cos 2 cos x. That is for y prime. So when we have y of 0, that is when x equals to 0, what do we get? We have C1 exponential 2 raised by 0, that's 0, plus C2 exponential 0 plus 2 sine 0 is equal to y of 0 equal to 0. Of course, here, what do we have here? We are going to have anything raised by 0 is 1. We have C1 plus C2 plus sine 0 is equal to 0. Sine 0 is 0. So plus 0 is equal to 0. So we can say C1 is equal to minus C2. We can call that one equation 1. Then we go to y prime of 0. Y prime of 0 is equal to 1. So y prime of 0, we have 2C1 exponential 0 plus C2 exponential 0 plus 2 cos 0 is equal to 1. So here we have 2C1 plus C2 plus cos 0 is 1 plus 2 is equal to 1. So here we have 2C1 plus C2 to be equal to 1 minus 1, equation 2. That's what we are going to get. So when we substitute here from equation 1, substitute C1 is equal to minus C2 into equation 2. What is equation 2? 2C1 plus C2 is equal to minus 1. Wherever I see C1, I change it to minus C2. So I'm going to get this to be minus C2 plus C2 equal to minus 1. Minus C2 plus C2. So that will be minus C2 equal to minus 1. Therefore, C2 is equal to 1. C2 is equal to 1. If C2 is equal to 1, what is C1? C1 is equal to minus C2. So C1 is equal to minus 1. So we have to find the value of C1 and C2. And we have been able to find the value of C1 to be minus 1. Therefore, C1 is equal to minus 1 and C2 is equal to 1. So this type of problem is called initial value problem because the value of the independent variable is the same. Yeah. So let's take notes. We should take notes. So thank you.